Hello again, this is Dr. Caleb Chen, and I want to continue with our discussion on using the Tukey Rule to determine outliers. And this time we're going to be using the graphical display, which is called the box plot. So just a quick review. I'm using the data about the 5 hourly wage data points for 5 different employees, and I changed the value from 20 to 50, and to make it an outlier, so to speak. And so 12, 15, 16, 18, 19, and putting them in an order array from the smallest to the biggest. That would be the 12, 16, 18, 19, and 50. And earlier we have set up the quartile measures, the 5-point summary, and the IQR, which is the difference between Q3 and Q1, that has pretty much the standard 50%. So that's why we call it interquartile range. That is 3, and plugging into the Tukey equation, and that would give us say the lower bound, which is 11.5, and upper bound is 23.5. And because 50 is greater than 23.5, we know that what is an outlier. Now let's turn it around and see how this can be displayed using a box plot. We call it a box plot, or sometimes it's called a box and whisker plot. So what I want to do is to set up a scale. Let's say we start from 0, and arbitrary 10, 20, 30, 40, 50. And above that, we are going to define the different measures, so that we know that the 18 is going to be right here, approximately 18. It is the median, and then 12, which is about here, it is the Q1, and then we have let me take back, is the minimum value, and then we have 16, which let's say is about here, is Q1, and Q3, which is 19. So it looks like most of these values are clustered around this area, right below 20. So first of all, and then what the final 50 is right here. So when we call it box plot, or the reason why we call it box plots, what is this reason? We are defining a box that is created between Q1 and Q3, and in the middle we have Q2, which is the median, and then we have the mean, which is 12, and max is right here, mean and max. And is a box that defines the standard to 50%, and here we have 25%, and you can see the biggest spread compared to right here, which is 0.25, which is the smallest spread. And this spread is between 18 and 19, and the spread between Q1 and Q2 is actually 16 and 18. But we also have a whisker that is extending from Q1 to minimum. So this spread here basically is another 25% of the values that are clustered around here from 12 to 18. But we also have a spread between Q3 and the maximum value is much bigger spread. In fact, what you can see, well, here's a box and whisker plot, because of the whiskers extending from the box. And needless to say, this spread is much bigger with the longer spread, the longer whisker, than the one on the left hand side. We have not quite talked about the Tukey rule yet and how it's applying. So let me see if I can get a different marker to show you these two values, 11.5 and 23.5. 11.5 is roughly here, because this is 12, so 11.5, let's say, is here, just a hair lower than 12. that would be the lower bound. And since what the 12 is the smallest value and is not lower than 11.5, so there's no outlier on the left hand side. But on the right hand side, 23.5, let's say it's about here, and this would be the upper bound value. And anything that falls outside this line or this vertical marker of 23.5 would be considered an outlier, and 50 for sure is an outlier. And even if say that someone whose hourly wage is $24 using the Tukey rule based on the data set that we have, well, it's still considered an outlier value. Not the person is an outlier, but the hourly wage in this case would be an outlier because of the data that we have. If we change the data around, well, it might be different. But we should note that what the factor of 50 is part of the data set does not affect the way we set up the boundaries, because what in no way has the value 50 entered into any of the calculations that we did earlier, like Q1, Q3 in the quarter range. And so that is the box and whisker plot. In this chapter, you also learn how to do the stem and leaf plot, and then also the dots plot. But to me, well, this is one of the most useful tools for managers, because then you can tell if there's any the value that lie outside the norm. And well, when they lie outside, well, they represent what the problems or sometimes opportunities that we need to be keeping an eye on. So much about this for today, and happy learning.